Institute, and also at the Department of Environmental and Occupational Health and Justice at the School of Public Health. He's a former acting chair or interim chair of the department. He directs the Translational Research Science Corps, I believe that's right, Tris? Translation Research Science Corps, for the center. He's done a lot of work around air pollution and health effects, as he discussed a little bit on the earlier panel, especially around traffic-related air pollution and health impacts on not only the lungs and the respiratory system, but cardiovascular effects, and now more recently, very interested in doing cutting-edge work on the effects of carbon dioxide on this inflammation and also cognitive and other effects on the brain. So it's my pleasure to introduce or welcome Dr. Kipen.
Thank you very much for that kind introduction. I was talking to the IT guy, so I'm not sure if Rob said it. He said I used to be the acting chair of the department, I believe. I'm not sure if he told you that I was the acting chair when I made the smartest decision I ever made, which was to hire Rob. So.
Was it to marry White?
Okay, so what you should know before I launch into this is there probably aren't more than about a half dozen people, if that, in the world who would give a talk anywhere near resembling this. This is rather off on a tangent. So what I want to talk about, first of all, is how much time do we spend indoors? I know people here know that, but I haven't heard anyone say it today. We spend in the Western developed world 80 to 90% of our time, the hours of the day indoors. What are the epidemiological associations between carbon dioxide and health? Just about none. There are no epidemiologic data on what health impacts carbon dioxide. There are lots of experimental data and physiologic data. And then supporting mechanistic data, that's what I'm going to talk to you about. So this is just to show you the kind of change that we're experiencing in carbon dioxide levels now. This is going back almost 1 million years, and we can see there have been these ups and downs over the millennia. And finally we get here to the around 2000. Here's the 1950 level, and we're up here around 400 parts per million, whereas we evolved somewhere between 200 and 300. So something's going on. We're worried about CO2 because it's a greenhouse gas. And I'm going to talk to you here today about health effects. I'm not going to tell you that there are health effects at the current level of 400, although it's conceivable, depending upon who you believe. So what do we think, where do we find elevated levels of CO2? Remembering, and this is why it's an indoor air pollutant, that we are the producers of CO2. Sure, your pilot light on the oven produces a little bit of CO2. If you're burning gas indoors, you produce CO2. But really, by and large, the sources indoors are the people there. We exhale it at about 40,000 parts per million. But basically, all our cells going through metabolism make CO2. Typically, in indoor air, that we see levels of about 600 to 1,000. They're higher than the outdoor air at 400 because we're making it here and it's not cleared all that fast from the room. Schools have been studied. I don't have any clever pictures of that, but schools have been studied a lot, and we do see levels of 1,000 to 2,000 in the schools, but nobody's ever really connected health effects to that kind of level, except for the so-called sick building syndrome, which is headaches, brain fog, if you will, fatigue, maybe some mucous membrane irritation symptoms, but not real quote-unquote health effects. Whoops. We do, I gave away my punchline, sorry. Looking in the bedrooms of people around New Brunswick, where we did a study looking at air pollution particles, we found that, and others have found that you can find these elevated levels of around 1,000 quite frequently indoors. And if you go to selected bedrooms where people are sleeping with their windows closed and the door closed, you can find levels at up to 2,500 parts per million. Not in most apartments, but some over the night. Aircraft, you can see maybe 1,300 parts per million, but when people are boarding, you can see up to 2,000 because the air handling systems of the plane, the ventilation systems aren't necessarily turned on. I mentioned vaguely tight buildings which are associated with the sick building syndrome, around 1,000 parts per million. NASA has established an acceptable level of 7,000 parts per million for astronauts hanging out in the space station. The Navy, for submariners who stay submerged and are totally on a mechanical ventilation system with carbon dioxide scrubbers, the Navy has established an acceptable level of 5,000. OSHA recommends no higher than 5,000, and I'm sorry, that's NIOSH, and OSHA has an established allowable limit of 5,000. So in terms of protecting workers, as in sailors and astronauts, we're nowhere near, we allow way higher levels than we do than are looked at and felt to have some mild health effects. This is just my fancy picture you can see. I was actually on a committee at the National Academy of Sciences 20 years ago now, where we established indoor air quality standards for submarines. And the standard we did for the Navy was 7,000 parts per million, meaning we didn't anticipate serious health effects at that level of 7,000. And then here's a couple pictures of astronauts. Same thing, they're living at 5,000 to 7,000 parts per million, and we don't really see anything wrong. Well, that all changed, at least in the literature. Not many people are aware of this phenomenon, but for some reason, scientists at Lawrence Berkeley Laboratories, in conjunction with a psychiatry faculty from the State University of New York at Syracuse, they did an experiment. I'm not 100% sure why they did this experiment, but they took healthy college students from UC Berkeley and at the Lawrence Berkeley Laboratory. Any of you see the movie Oppenheimer? So Lawrence, that lab's named after him. They tested these students in the morning. They gave them very difficult tests of executive function, which are labeled down here. Whoops. The difficult tests could be divided into these domains: basic activity, applied, focused, task orientation, initiative, information search and usage, breadth of approach, and basic strategy. These are executive functions that they tested by giving people validated and reproducible scenarios where you're like the mayor of a small town, a tanker truck turns over, or there's a mass shooting. How do you handle it? How do you deploy people? How do you deploy your resources, fire departments, ambulances? And to try and do these tests quickly. These were felt to be much more difficult than arithmetic tests and typing speed and more traditional tests of cognitive function, but not necessarily executive function, which never showed any problems with CO2. But they tested these students in the morning and in the afternoon in a counterbalanced way, so sometimes they got the CO2 exposure in the morning and sometimes they got it in the afternoon. And they tested it at 3 different levels. 600, which is well below where submariners live, where people boarding airplanes live, and really what we expect to find indoors. Maybe this room now would be around 600. They tested them at 600, 1,000, and 2,500 parts per million. So all of that is well within what you can run into in everyday life. And you can see up here that the higher it was, the black, the worse you did. Down here in the 25th percentile, dysfunctional, all these tests. And this was all highly significant. The medium exposure showed much milder effects. That was kind of remarkable. This is a little more scary. It's a little less remarkable. With colleagues of memos at Harvard, they did a test looking at professional airline pilots in a simulator, which is supposedly a pretty good simulation. And the pilots, looking at similar levels of CO2, 700, 1,500, and 2,500, so the same range, for a couple of hours is all, they did, on what was called the passing rate, they did significantly more poorly at the 2,500 than either of the other levels. And the medium 1,500 was kind of in the middle. So this is something you can kind of relate to if you fly in airplanes. The pilots didn't do as well. Now, all honesty, they actually didn't flunk the computerized scoring system, but having other pilots observe them, more senior pilots, they thought they were not performing optimally. And that's what these ratings are. So there's some reason to believe, based on experiments with humans, not epidemiology, there's some reason to believe that carbon dioxide at levels we all experience are impairing our cognitive abilities or our executive function. So I got interested in this little divergence here because I was on a National Academy committee after the submarines just 2 years ago, 3 years ago. And this committee had been hired by the United States State Department to advise them on how to protect their diplomats who were and the diplomats' families who were stationed in really dirty cities like New Delhi, Beijing. Used to be, Beijing's much cleaner now. Other cities in South Asia. They wanted advice on how to protect them. And we really, at first in the committee, we said, wow, these people are really smart because they'd already taken measures to keep outdoor air pollution from coming indoors in their homes. They sealed around their doors. Somebody mentioned caulking before in PCBs. I think it was Alan. You know, they caulked windows so that no dirty outdoor air could get in. And we were just thinking about it as a committee and said, well, wait, what's going to happen to the CO2? Because the CO2 couldn't get out. So based on that, we found, or I found the other two studies I just showed you. And then in a review paper, actually it wasn't, it was in the references from the airline pilot paper. I found this paper in 2017. A guy at the University of Maryland took mice and exposed them for 2 hours, the same as more or less the airline study and the student study at Berkeley. 2,000 or 4,000 parts per million. So again, not all that high. And they found evidence of inflammation in the blood. The neutrophils, which are infection-fighting white blood cells, were turned on. And so were the platelets, but we're not going to follow that very far. The cells showed subclinical levels of inflammation in the blood vessels as measured in these cells, very similar to the inflammation seen when outdoor air pollution goes up. We can see the same sorts of markers changing in cells, but nobody feels sicker when the outdoor air pollution goes up. You may be annoyed, irritated, or but you're not really sick. So they found these cellular changes, which are remarkable, but even more remarkable is they found leakage of fluid in the brain and in other tissues, which could be seen on a microscope slide. So the blood-brain barrier, which has been mentioned earlier, was somehow being altered, we think, by the carbon dioxide. This is a lab experiment. Everything else was controlled, and they were having different levels of carbon dioxide. So this fit in with the previous data that shows cognitive impairment of executive function in the same subjects. Now, they didn't do any behavioral testing in the mice to know if the mice weren't thinking quite perfectly. So, what happened? Is this a done deal? Does the EPA have to come out and regulate CO2 in indoor air? The EPA, by by the way, I'm not sure if this has been mentioned. EPA, oh, it has, by Alan. EPA doesn't regulate indoor air for anything, let alone CO2, which by and large we as a society think is not that bad. It's just maybe a marker of inadequate ventilation. So, summarize this, 3 out of 4 studies, there are actually 2 others, one run by the Navy which didn't show anything, but it was not an optimal study design. Comes down to, we said, well, what can we do next? And so we're in the middle of an NIH-funded study right now, which is doing the same thing we did before, having them take the cognitive tests, measuring the inflammation in their blood, humans. But we're then sending them for MRI scans. How many of you have ever had an MRI? Okay, we're sending them for MRI scans of their brains almost immediately after they have the CO2 exposure. And we're in the midst of that. We've run 4 subjects. We think 12 is going to show us what we're looking for. And so you have to come back next year to find the answer to that. This is our facility for doing controlled exposures with 2 of our techs. This is, well, a lot of you saw our chamber when you we hosted it at the Institute a few months ago. So this is the steel chamber in which we have subjects breathe the CO2. They're not on a bike for our study. They're actually at the computer console taking those cognitive tests. And so with that, I think we're done. Oh, one other thing. Why are we doing this? Why doesn't EPA just take the data that has been shown in humans on the cognitive test and say, this is a problem, we got to go for it? Well, these 8 things, and I'm not going to go through all of them with you because we don't really have time, but these 8 things as ways to summarize the scientific literature and say, do we have a causal relationship or do we not have a causal relationship? One of the elements of that, besides that the stimulus has to precede the outcome, how strong the outcome is, this is over multiple papers. Is there a dose response? Yes, there is, because the lower doses of CO2 produce effects, but milder effects than the high doses. Well, you come down here, and number 6 is biological plausibility. If there's biological plausibility, then we're much more likely, as scientists and regulators, to believe it. Biological plausibility is mechanism, and that's what we're trying to show. We're trying to show that the brains are actually, and the fluid in them, are actually affected by the CO2. And if we find that, plus the previous literature, there just may be a movement to start to regulate. So that concludes what I have to show you.